Good morning, my dear students. So, we already learned about that solubility, then the factors affecting solubility, and there's four factors. These are nature of solvent, then second one is nature of solute, third one is temperature, and fourth one is pressure. Okay, so we already learned these things. Today we are going to learn about that effect of temperature. We learn about that when in liquid substance, if solid is dissolved, then what happen if we increase the temperature of the system, then how it affected. Okay, we are going to learn about this now. So in case of effect of temperature, what they that the solubility of a solid in a liquid is significantly affected by temperature changes. Already they told that if we dissolve a solid in a liquid, then it affected by temperature increasing. And in how it affect, in this case it follow that Lee Chatterjee principle, which I already discussed in my first year in class 11, during a chapter thermodynamics. There we learned that. And in equilibrium we learned that. And about these things, that enthalpy, in this about this enthalpy we learn in the thermodynamics. Okay, so according to this principle, what happened? Okay, let me explain it in a board. Okay, so according to this literature principle, what happened if we increase, in case of endothermic, we all know about that endothermic. Endothermic means where heat is absorbed in a reaction. Then in case of endothermic, the LH value is positive. Okay, so let me give an example of a reaction. And if R produce P, where R is the reactant and P is the product, it's an example of reaction. So in case of endothermic, what happened? Heat is absorbed by the reactant. Okay, so if we increase the temperature, what happened? We know that according to literature principle, what happened whenever yes we have to change something in that, then the reaction automatically go forward or backward direction to maintain its equilibrium. This is all about literature principle. Okay, so since we increase the temperature, so what happened? This reaction is goes to this product direction, because see, yes, already the temperature is there, and if when we can increase the temperature, then this side will be more and this side will be less. But in case of literal principle, what we have to do, that we have to maintain the equilibrium in both sides. We have to the same weight. Okay, so since we increase the temperature, the reaction is in the forward direction, and then solubility is increased. So you remember these things. Okay, that if the LH is positive, that means in case of endothermic reaction, when we increase temperature, solubility is increased. You remember this thing. Okay, and then in case of exothermic reaction, what happened? In case of exothermic reaction, we know that the LH equal negative. Okay, that means heat is evolved. Okay, heat is evolved in this reaction. So here if we increase the temperature, what happened? The reaction is proceed in backward direction. Okay, so what happened? Solubility is decreased. That is all about Lee Chatterjee principle. Okay, so now I am going to that our chapter. Okay, so here these things are written here, that when the process is exothermic, When the process is endothermic, that means the LH greater than 0, that means the LH positive, the solubility should increase with rise in temperature, which I already told that when temperature increase, solubility increase. Okay, and in case of exothermic, when the LH is less than 0, that means the LH is negative, then solubility should decrease. Then solubility should decrease with increase in temperature. Okay, that's it all about. And now we are going to that effect of pressure. When we dissolve a solid in a liquid, what happens? This pressure doesn't have any significant effect on solubility. Why? Because mm, we know that liquid and that solid are incompressible. If we press them, then also their shape is doesn't change much. Okay, so they are highly incompressible, and because that solid and liquid are highly incompressible, that's why they are practically remain unaffected by changes in temperature. So in case of whenever we dissolve solid in liquid, there's not any effect of pressure. Okay, remember that. Okay, so now we are going to learn about that when we dissolve a gas in when we dissolve a gas, in liquid, then what happened? Okay, see here, solubility of a gas in liquid. Okay, so here that we know that many gases dissolve in water. We know that oxygen dissolves in only small extent in water. Why oxygen is dissolved only small extent? Because yesterday I told about that when there is a polar solvent, when there is a polar solute, it dissolves in only polar solvent. Okay, but here oxygen is non-polar. Okay, because both of have same electronegativity, so they don't have any charge. But water is polar. I already told about that water is polar. So why non-polar thing is dissolved in that H2O, right? That's why oxygen dissolve in very small extent. Oxygen dissolve only in small extent in water. But there's a thing that we know that oxygen dissolve in very small extent in water, but this dissolved oxygen have to sustain aquatic life. I mean those fish, those trees which are in that inside that water, and those pieces are live with this large amount of, with the help of this large amount of oxygen which dissolve in very small extent, but aquatic life is live sustains with the help of this oxygen only, this large amount of oxygen. Okay, so on the other hand, hydrogen chloride gas is highly soluble in water. Mm, Now, if I ask you that question, that why hydrogen chloride is highly soluble, maybe you can give the answer because HCl in HCl chlorine is highly electronegative, so it have negative charge and hydrogen have positive charge. So that means it's also polar, and we know that H2O is also polar. Okay, so what happened? HCl dissolve in H2O very easily. Okay, so solubility of gases in liquid is greatly affected by pressure and temperature. We know that because gas is compressible. Here we learn that solid here we learn that solids and liquid are highly incompressible. That's why effect of pressure is not there. But in case of gas, if we press it, then it will be like this. Gas will take very less space. Okay, so since gas is compressible, that's why there's a pressure effect of pressure is occur, as well as effect of temperature is also occur there. Okay, so now we are going to learn about this here, that the solubility of gases increase with increase of pressure. Yeah, obviously if we increase the pressure, then solubility of gas increase. Here it's an example we have We should learn it from here. Okay, see here only one weight, that's why it have less pressure than it's, because here are three weight over there. Okay, here since the pressure is less here, so gas molecule have more space. Okay, so gas molecule have more space, so they doesn't dissolve completely. But in case of here there's too much of weight, so pressure is more, so gas is compressed and it's dissolved with water very easily. So when we tell like that, we can say like that, that whenever we increase the pressure, then solubility is increased. Okay, in case of gas molecule, remember that whenever we dissolve a gas in liquid, then when we increase the pressure, then the I mean that when we increase the pressure, then solubility is increased, which is written here. The solubility of gas increase with increase in pressure. Okay, so now okay, then here in for solution of gases in solvent, consider a system as shown in figure 2.1. We already we already learned that the lower part of solution and the upper part is gaseous. We know that in the lower part there is liquid and in the upper part there is gases. Okay, so and the system at pressure P and temperature T. Okay, then assume the system to be a state of dynamic equilibrium. Okay, in if it is in dynamic equilibrium, then what means that when there is equilibrium, this means under this condition rate of gaseous particle entering and leaving the solution phase is same. It means that when there is equilibrium, then there is liquid and there is gases, so the rate of gases go to this liquid and the rate of gases out from this liquid is the same. That means it is in equilibrium. Okay, so now increase the pressure over the solution base is compressing the gas to smaller volume. Yeah, I already told that when we increase the pressure, then solubility gas is easily soluble to that liquid. Okay, this will increase the number of gaseous particle per unit volume of the solution and also the rate of the gaseous particle striking the surface of solution and through it. Okay, this is just the line that whenever you increase the pressure, gas have very small area, and that's why it dissolve with that amount of liquid very easily. Okay, okay, so yeah, so with the help of this Henry, who is a scientist, okay, he gave a law which is denoted as Henry law, and this is the most important question which asks in everywhere, every year. Okay, so you just remember that you have to remember that what is it, that law. Okay, you have to remember that the solubility of a gas in liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. I think it's quite easy for you guys now, because see what is written there. Here they tell that the solubility of gas, that means the solubility of gas, that means there's liquid and there gas, and the solubility of gas in liquid. Okay, gas proportional to, it's proportional means that solubility is proportional to the partial pressure of the gas. Partial pressure means we give the pressure. If we give the pressure much, if the pressure is much, solubility is more. If the pressure is less, solubility is less, right? So that means that solubility is directly proportional to that pressure, right? So this is all about that Henry law, and I think it's quite easy for you guys now, because we know that whenever we increase the pressure, then solubility is increased. Whenever I decrease the pressure, solubility is decreased. That means solubility and pressure is directly proportional to each other. Okay, we know these things from here. If the pressure is less, then solubility is also less. If the pressure is more, then solubility is more. That means solubility is directly proportional to pressure. That's it. Okay, so that's it all about that Henry law. Okay, I think it's quite easy for you now. And Dalton, a contemporary to Henry, also concluded independently that the solubility of a gas in liquid solution is a function of partial pressure of the gas. Dalton, he is also a scientist. He also told that solution is a function of partial pressure, which means that that solubility depend on that pressure. Everything is like that solubility depend on that pressure, and it's directly. If we increase solubility, if we increase pressure, solubility is also increase. If we decrease pressure, solubility is also decrease. Okay, so according to Dalton, he gave that idea about that if we use the mole fraction of gas in the solution is a measure of solubility, then it can be said that okay. Now we get the term that mole fraction. Do you remember that mole fraction? We already learned it in that concentration part when we learn about that how we can measure concentration with the help of mole fraction, with the help of molarity. Okay, so Dalton, he gave the idea that if we take that mole fraction, okay, so mole fraction of a gas in the solution is proportional to the partial pressure of the solution of the gas over the solution. Okay, don't feel confused about it. Okay, I'm going to explain it very well. You just concentrate that. See, we know that solubility depend on concentration, right? We know that because whenever we have learned this thing in our next class. If you forget that, please check the last video. Okay, so whenever concentration is increased, that gas particle and that solid liquid particle, they have very good if the concentration is increased, that means solubility is also increased. Okay, that means solubility and concentration are same, like. Okay, so whenever concentration is increased, solubility is also increased. So in case of solubility, we can take that concentration. Okay, and concentration should be explained in terms of mole fraction, molality, and molarity. So Dalton take that mole fraction. Okay, Dalton take that mole fraction. So maybe you guys are understand it very well now. We know that solubility is increased with increases pressure. Okay, and again solubility is increased with increased concentration. That means we can write like that, right? That when pressure is increased, concentration is also increased. Okay, so we can and concentration is like mole fraction, molarity. Okay, so in case of that solubility, we can use that concentration term, mole fraction. So it's quite easy now. Mole fraction is also proportional to that partial pressure. Okay, so according to Henry, it's that solubility is proportional to that partial pressure, and in case of Dalton, mole friction is proportional to that partial pressure. These are easy, right? So the most commonly used form of Henry law state that, see, we already see that Henry law statement, but there's two or three statement for that Henry law, so you should remember anyone, but it's the more efficient. If you write this in your exam, then it will be more good. Okay, so here it's that the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. Okay, so Henry told that solubility is increased with increase in temperature, and Dalton told that concentration, mole fraction, is increased with increase in pressure. So Henry law could be explained it in very way with the help of this mole fraction. Okay, so The correct statement of this Henry law is that the partial pressure of the gas, that means pressure depend on pressure proportional to that concentration term and its molarity. Okay, so whenever we increase the pressure, mole fraction is also increased, and whenever we decrease the pressure, mole fraction is also decreased. So I think it's easy for you now. So guys, today you have to write that what Henry law is, and you have to write this statement. No need to remember it, you just practice. I mean, you have to just understand it, because the partial pressure is proportional to mole friction, and what mole friction is? Mole friction is that concentration. We already learned that pressure increase, solubility increase, concentration increase. That means pressure increase, concentration increase. So pressure is directly proportional to that concentration, which is also denoted by, concentration is also denoted by mole friction. Okay, or molarity here they use mole fraction. Okay, so the equation of this Henry law is pressure directly proportional to x is mole friction. We already learned that, right? We already learned that in, I mean, mole friction in terms of concentration. Okay, so if we remove that proportionality sign, then there is a constant, and it's known as Henry law constant. Okay, so that's it all about today video. In my next video I am going to teach you about more about this Henry law and that equation, and see if it's problem to explain it in here, then I'm going to solve these things in whiteboard. Okay, okay, and okay, if you want to see that mole fraction is denoted by that x, then wait a second, there we learn it about here. Okay, we learn that it's it's a concentration time, right? So in case of concentration, you should write mole friction, molarity, and molarity. Dalton and Henry, take Dalton take mole friction as concentration term. So they use in Henry law, we use that mole fraction only. Okay, so we know that mole fraction is denoted by this x. Okay, so this chapter is really very important, and in this chapter what you learn that everything is related to each other, so you have to learn it from basics. Okay, so if you don't watch that previous video, then don't miss it. First you have to watch that previous videos, then you should watch this video. Okay, then you are going to learn it very well. I checked this that very less people, very less students could see those videos. So what are you doing, guys? You have to watch this, otherwise it's become a problem for you in your future. If you learn these things from now, then it will be helpful. And yeah, that's it all about for today's video. In our next video we'll learn about that Henry law explanation and that equation. And yeah, if you have any question, you should ask me, you should comment me. And yeah, that's it all for today. Take care a lot, study very well.